Okay, and here we have getting into the mortgage type problems. Total interest paid on a home mortgage is blah. And I don't expect you to derive these formulas. This would be provided. But now you can manipulate it. Consider a $200,000 home mortgage at 7.5%. So the point is, I'm giving you P is 200,000 and R is 7.5%. Approximate the length of mortgage for which. So you want to find length of mortgage for which the total interest paid is twice as much as the original loan. So I guess here you need to know what T is doing. It says the total interest paid on a home mortgage for T years. So this is what this formula is actually telling you. You have to read the question very carefully. T tells you is how many years in the mortgage. Okay, so this isn't the same as your homework. Maybe it is, but it's you have to read the question in any case. Okay, so it could be 10, 15, 30. Those are typical values. Okay, 30-year mortgage. And so let's just pick normal values that we would figure that we would have, and just get a ballpark here. All right. Well, this is sloppy, right? This is a sloppy formula. So I would pull up Wolfram Alpha, except that it's on an exam, so we can't. So let's take another approach. Let's just solve the approximate the length of mortgage for which the total interest paid is twice as much as the original loan. Okay, so total interest paid, let's see, it doesn't matter that it's 200,000 and 100,000. And so let's just figure out R is 0.075. Here's T. And the denominator is going to look like this. 1 minus 1 over 1 plus 0.075 over 12 to the 12t. Okay. Yeah, and if that's 200,000 and 100,000 and all that stuff, so if I just put P was 200,000, then U would be 400,000. But then I'd divide it out, and it would look like this. Now, this 1 over here is gonna move, right? So because I've already divided out by those awful big numbers, I can get rid of all these parentheses. And then the 3 is going to go to the other side. So I'm actually going to turn this guy into a 3 and get rid of this. Alright. And this is where we started on the practice exam. This is the first step I showed you. But that's how I got that stuff. Alright, now what I'm going to do is I'm going to multiply through by the denominator. Right? So I'm going to get 0.075t on one side. Okay, so I'm going to get 3 minus 3 times this mess. Okay, so I'm going to erase all this so that I can have the space back. And then I'm going to move stuff around. I'm going to say 3 minus 0.075t. You know what? I would like to know what this is. So I calculate this denominator and get 0.00625. There we go. It's getting better, but not quite good enough. And I would like to convert 1 over 1.00625 to a number that isn't a fraction. And there we go. This is where I'm going to stop and split it into two functions. Now you can keep going with this. It depends how comfortable you are with your calculator, but you could, you're not going to be able to solve for t. Okay, you're going to have to do this numerically. You certainly have the natural log trick to take care of this t, so if the only thing that were unknown was just that t exponent, that would be fine. But that's not the only thing you have to deal with. You have another t down here, which is going to be a pain. So I put the line on the left and the exponential function on the right. And I'm going to just pick t's that are typical mortgage values. I'm going to call this guy f and this guy g, and they don't have any physical significance. They're just numbers I'm pulling out of the air, or just letters. I want to see when the function f and the function g are equal. Now, why did I do it this way? Well, I have an intuition about what lines do, and I have an intuition about what exponential functions do, and so if I set them up one beside the other, that should help me figure out what's going on. So I'm going to start with a 25-year mortgage. I don't know why. Alright, and I calculate f, and it turns out that it's 1.125. And again, I have no idea what this means. I calculate g, and it's 0.4628. Oh, the other thing you should know is f has to decrease, and g has to increase, right? Or actually, it's going to also be decreasing, but it's going to be decreasing slower, hopefully. If they're decreasing at about the same rate, then we're in for some trouble. Hopefully, they're not decreasing at the same rate. That 0.993 should keep it a lot more stable than the f. Okay, so here are some values I just picked. And here's what I get. So on an exam, I would give you hints. I would say hint, try, 25, 30, 35, 40 for t, and see what's happening to the function. And then it doesn't really matter how you split it. You'd still get to the same rough conclusion. So you see g is decreasing, but it only decreased by, 0.3, whereas f decreased by 1.125, and at some point they had to cross over, right? So here, at t is equal to 35, we have f greater than g, and then at 40, g is greater than f, somewhere in here. It says approximate the length of the mortgage. So, somewhere between 35 and 40 years. If you wanted it down to the year, you could. If I said approximate to within a year, then after you did these big steps, you'd refine your search and say try 36, 37, 38, 39, and then you could figure that out. But that's good enough. I mean, that's all I'm asking for.